وصحبه أجمعين. We are still in section 3.1, and this is the last question we solved yesterday. It was about the mean, the median, and the mode. We found that the mean or the average of this data, which is a population, is 2.417, while the median is 2.5. The median is 2.5, and the mode is 3. And then he asked the question, based on these measures, can you conclude that the distribution of time spent at customer locations is skewed or symmetric? So the distribution of the variable, which is here time spent at a customer locations, has a shape. Usually the distribution has a shape, and we need to learn how to differentiate between the shape when it is symmetric and when it is skewed. So let us have a look. Please read this table before. In this table, there is a comparison between, or there is a summary of all the three measures of center, mean, median, and mode, the computation method of each one of them, and the data level used with each one of them, and the advantages or disadvantages, which is the characteristics of each one of them. So this is a summary. Always look at this table. Here also there is a comparison between the mean and the median, and this comparison is important to understand the shapes of the distribution. Here we have 2, 4, 6, 7 values, 7 salaries. And if you calculate the mean, you will find it 51,000 and the median 52,000. So this is the mean and the median for these values, salaries. If you add one large salary, $2,300,000 to these 7 salaries, then you will get 8 salaries. Now you have 8 salaries. So if you remember, the median is the number in the middle. But this is in fact the number in the middle because you have 7 salaries, 3 to the right, 3 above, and 3 below, especially if the data is sorted like here. So the median is 52. But if you have 8 numbers, then the median cannot be 52 anymore. It would be in the middle between 52 and 56. So if you add 56 plus 52,000 over 2, you will get 54. So here the median is 54, while the mean, really it is not a big change from 52 to 54, but the mean dramatically changed because you added a value of 2,300,000 to the salaries. So instead of 51,000, it's now 332,000. That's too many, too much. So this makes you understand that the extreme values, this is really an extreme salary, large extreme salary. So the extreme values will pull the mean to their direction, So this salary is larger than all the others, so the mean would be larger than the previous one, much larger. If this salary is small, very small, مثلا 1,000 or something, then the mean will go to that direction, will be smaller. Okay, so the mean follows what we say, what we know as what we call as skewness. Okay, so the median is not affected by the extreme value, but the median is not affected. So if you have extreme values in the data, the median would be a better and useful measure of the center in these types of data. If the data are highly skewed, then use the median as a measure of the center because the mean will be affected by the skewness. How? The mean will go to the direction of the skewness. Okay, so here this data is called left skewed. Why do we call it left skewed or negative skewed? Because there are numbers here to the left, and these numbers makes this left tail. There is a left tail here, while the majority of the data are in fact to the right. You see this because the graph is here, the curve. There are a lot of data here to the right. So that's why the mode is here. Of course, it is easy to determine the mode because the mode is the most frequent. So it's the highest point. So the highest point is always the mode, whether it's left skewed or right skewed. Right skewed when we have a right tail. So there are minority of data to the right, but we have numbers like مثلا if this is 50, so most of the data here 50, 60, 70, 40, but there are 0, 0, 1, 2. So they are pulling the shape of the distribution to the right, making a right tail. So the data would be right skewed, although most of the data would be around here 50, 40, 60. So the mode is the highest number, the highest value. Now, where is the mean? Which one of these is the mean? Is it this one or this one? Where will the mean go? And here you need to understand that the mean is affected by these extreme values. So here in the left tail, we have the extreme values. Here in the right tail, we have the extreme values. So the mean will go to the direction of the extreme values. Okay, so that's why the mean is closer to the extreme values from the median. So the mean in the left skewed distribution would be to the left of the median because it goes to the direction of the skewness, and the mean in the right skewed data would be to the right of the median because it goes to the direction of the extreme values. While the median keeps its position, it's always a value in the center. So 50% of the data are to the right of the mean, and 50% of the data are to the left of the median. So the median is always the center value in the middle, 50% to the right and 50% to the left of the median. So this is how to differentiate between the position of the mean and the median if you have left skewed or right skewed data. If the data is not skewed, if the data is symmetric, and symmetric means the data to the right of the center is equal to the data to the left of the center, then the mean and the median and the mode will be in this case equal. So if the data is symmetric, all these three would be equal. This shape is in fact called a mound shaped, and the mound shaped is one of the symmetrical distributions because it is symmetric. But there are other symmetrical distribution. You can sketch a graph like this, for example. Okay, this distribution is symmetric because if this is the middle here, this is the middle. Here in the middle, you will have all the three. You will have the mean and the median and the mode. They will be equal in the middle, and half of the data to the right and half of the data to the left of the center. So this is a symmetrical distribution. This is also symmetrical distribution, but this one especially is called a mound shaped, and we will study this shape in chapter 6 again. It is also called normal distribution. Normal distribution. Chapter 6 will be about normal distributions. Okay, so symmetric data values. Here the values are evenly spread around the center. So half of them to the right, half of them to the left. For symmetric data, the mean and the median are equal. For skewed data, these data sets are not symmetric. For skewed data, the mean is larger or smaller than the median. It would be larger than the median if the data is right skewed. The mean would be smaller than the median if the data is left skewed. So here, symmetric data, mean equals median. Left skewed, the mean will go to the skewness, to the left. Right skewed, the mean will be in the right, to the right of the median. So now we can answer this question. Based on these measures, can you conclude that the distribution of time is skewed or symmetric? Well, we found that the mean, which is 2.417, is smaller than the median, which is 2.5. So this means that the distribution is, although the difference is not really big between them, so I'll say slightly, okay? Slightly, so the distribution is slightly skewed to the left. Why the left? Because the median is 2.5 and mu is 2.41. It is to the left of the median, so the distribution must be somehow skewed to the left. We have a left tail. So this is the answer of this question, and we finished talking about types of distributions, and now we go to another important point, which is the last measure of center or location, the weighted mean. Please try to understand what is the weighted mean. This is a very important type of measures. The unweighted mean is the mean that we know, the average. You add the numbers and divide by a small n or capital N. But what would happen? How to find the weighted mean? There will be weights, okay? فالmean here, the mean value will be, we will have values that have been weighted according to some measure, okay, to their relative importance. So we have weighted values, okay? So in this case, to find the weighted mean for a population, we call it mu W. For the sample, we call it x bar W. We multiply all the values, xi, each value, times the weight of each value. So wi is the weight, xi is the value. We multiply xi times wi plus x1 times w1 plus x2 times w2 plus and so on, and we divide this sum by the sum of the weights, summation wi. By this we evaluate the weighted mean. Let us take some examples. First example is an important example for you. You can use it in this course actually. A professor wishes to develop a numerical method for giving grades and all of your courses. You need this example. You need to understand this example for in all of your courses. He intends to base the grade on, okay, so the grade, your grade in the course would be based on homework, 2 midterms, a project, and a final exam. Well, this differs from a course to another. So here in our course, we have all of them, but we have also quizzes and we have participation. Okay, so you can add quizzes and participation. He wishes the final exam to have the largest influence on the grade. And this is always the case. We need always the final exam to have the largest influence. And the reason, because the final exam is comprehensive and it includes all the material. So it should really weigh more than all other points. He wants the project to have 10%. Okay, so the project, 10% of the score will go to the project. Each midterm, 20%. So midterm 1 will have 20% and midterm 2 out of 20%. our project is 6%, not 10%. Okay, he wants the project to have 10. Okay, and the homework 10. احنا الفاينل الهومورك is not 10. عندنا برضه الهومورك 4 I believe, I'm not sure. What about the final exam? He didn't say. Each midterm 20, the homework 10 of the influence on the semester grade, and he didn't mention what would be the way of the final exam. Determine the weights the professor should use to produce a weighted average for grading purpose. To produce a weighted average, we have to find the weight of the final exam. To find the weight of the final exam, you add all of these. Okay, 10, 20, 20, 10, 10. If you add all of them, you get 60. If you subtract 100 minus 60, you get 40. So the final exam will weigh 40%. Okay, so this is the weight of the final exam, 40%. Okay, now this is part A. Part B, for a student with the following grades. So these are the grades of a student during the quarter. He got 89. 89 in the homework. 89 out of what? Okay, 89 out of what? Out of 100. Why? Because he said percentage grade, percentage. So this is 89 out of 100, 63 out of 100, 67 out of 100. So all of these scores are out of 100. How can he find out his grade in the course? What would he get? A, B, C, or D, or A? Okay, what is your grade? What will be your grade in this course if you have all of these scores? How can we say? If we say, okay, the weights are not important, it's not important that the final weights 40%, project 10%. I'm not going to look to these weights. I'll just calculate unweighted average. Unweighted average means of the scores, or of the grades. You add the grades, 64 plus 98 plus up to 89, and you just divide them by how many scores are there. 2, 4, 5, 5. خلاص, you get the answer. This would be your score, your unweighted score. Okay, 64 plus 98 plus 67 plus 63 plus 89 divided by 5. The answer is 76.2. So you get C plus in this course. But then the professor will say, oh, come on, how come you add all of them? You don't pay attention to the weights. The final weight's 40%. You cannot do like this. This is a usual mean. This is an unweighted mean. I need a weighted mean because the final exam shouldn't weight the same as the homework. Okay, there must be a difference between them. So how to find the weighted average for this course, for the grades? The weighted average of the grades would be summation Wi times Xi. Where is Wi? The weights. These are the weights, 40, 10, 20. So to solve part B, you multiply 64 times 40 plus 98 times 10, and so on, up to 89 times 10. This is summation Wi(xi), and you divide by the sum of the weights, 40 plus 10 plus up to 10, which is 100. If you evaluate this, you will get 70, I think. Let us do it. You will get here 7030 over 100. So the answer would be 70.3. So you received C, not C plus. Okay, because the final is more important than the project. Although you got 98 in the project, but you got 64 in the final. This is the weighted average. This is a very important example about the weighted average. Another example, The La Costa Corporation operates 5 manufacturing plants. So this company has 5 plants in South America. The company tracks the medical costs that are directly attributed to accidents that occur at the plant each year. So we are concerned about the medical cost. So the medical cost of the first plant is $7,000. The medical cost of the second plant, $14,000. The last one, $3,000. How come? Why these differences between the plants and the medical cost? Okay, if you don't find the factor, what affects the medical costs? Of course, what affects the medical costs is the number of employees who work at each plant. How many employees are there? There are, in plant 2, we have 402 employees. In the last plant, we have 67. Do you expect that the medical cost of 400 employees will be equal to the medical cost of 67? Of course not. So the number of employees should be taken into account if you want to find the weighted average for the annual medical costs. And pay attention here, we need to find the weighted average for the annual medical costs. So where are the weights here? We have two data. We have medical cost and we have employees. Which one of them is the weight? How to understand that? You understand that from the question. Look to the question carefully. Compute the weighted average for the annual medical costs. So the other variable would be the weights. So the employees, the number of employees would be the weights. Or you can do like this. You can ask yourselves, forget about the weighted, this word, forget about it. Find the average medical cost. If I ask you a simple question, what is the average medical cost? Okay, unweighted average. You will do what? You will add 7, 400 plus 3, 100, and you will divide by the 5, which is the number of plants. This is the unweighted average for medical costs. Okay, now find the weighted average. Weighted average, you multiply each one of them by its weight. So you understand immediately that the weights here are the number of employees. So to answer part A, the weighted average would be 7,400 times 123, okay, plus up to 3,100 times 67. And you divide by the sum of all weights, which is here the number of employees, 123 plus 67. And by this, you get the weighted average. Explain why La Costa would want to use a weighted average. Of course, because the number of employee should be taken into consideration. Okay, the number of employees should be taken into consideration. A plant with larger number of employees should have more medical cost than the other one. This is something trivial. Okay, the last example today, also about weighted mean. A commercial real estate company owns 6 office buildings. Okay, we have 6 office buildings that it leases to businesses. The lease price per square foot differs by building due to location and building amenities. Okay, so the price differs from a building to a building. The price per square feet of building 1 is $75. The price per square feet of building 6 is $120. Why? Why there is a difference in the price? Because of the location and the building amenities. Currently, all 6 buildings are fully leased at the prices shown here. So these are the price. This is the price per square foot of each building. If he asks you, compute the average, forget about weighted, the average mean. See, do you see this? Okay, average or mean, the same. If he says average or mean, that's exactly the same. Compute average or mean price per square foot for these buildings. If this was the question, forget about weighted. What would be your answer? You will add all the prices, 75. Okay, let us do it. 75 plus 95 plus 120, and you will divide by 6 because there are 6 buildings. This would be the average, the usual average or usual mean price per square. But is there anything here to take into consideration? Yes. What is it? The number of square feet. Building 1, 115 square feet, the area of building 1. The area of building 4 is 35,000 only. So there is difference in the area. So the price of building 1 would be much higher than the price of building 4. So if you want to find the price per square foot, you have to take into consideration the number of square feet. So the number of square feet would be, in this case, the weights. So you multiply by 11530 zeros and 95 by 36500, and you continue like this until you multiply 120 times 120,000. Okay, 120,000, and you divide by the sum of number of square feet, and then you will get the answer, the weighted average price per square foot. I stop here, and inshallah tomorrow, not tomorrow, after that we will continue the last parts of section 3.1. If you have any question, please